Alright, hey, so welcome to a video I'm going to do about RO units, which if you're not familiar, that's reverse osmosis. It's basically filtering water by pushing it through a membrane that's got really tiny holes in it that holds all the bad stuff out. Of course, the downside is that bad stuff has to go somewhere, so it gets flushed away with extra water. So it uses more than just drinking water out of a tap or through a normal filter. But you get cleaner water. And I'm going to kind of test that by using TDS tester, and I've got two different types of RO units that I'm going to go through how both of them are hooked up and installed, and it's going to be real exciting for the other one because I might just shock the hell out of myself. Yeah. We're going to start off, I can't do all four at once because I only have one sink with an RO unit attached to it right now until I put the new one in. But right now I've got right here tap water, then refrigerator with the filter water, and then I've got the actual reverse osmosis water from the unit with the tank. And we'll start off by doing a quick test of all of those. So you can see here I got my tester, it's reading 0. And we'll start off with the tap water to see how that one reads. And right here it says 344. You're probably not going to be able to see that because, you know, it's impossible unless I bring the camera up there. But here, I'll bring it close enough so maybe we can see. All right, so here we are with the tap water. This one has a rating of 341 parts per million. That's pretty normal from what I can tell. It's not anything super special, but pretty standard. So moving on, we'll do the refrigerator water. All right, so here we are with the refrigerator water with the filter, about 324 parts per million now. The number kind of goes up a little bit over time here, so it's kind of interesting. But yeah, it's still not any better really than the tap water. It's a little bit better, but it's about the same. So refrigerator filter, even though this is a pretty new filter on this refrigerator water, doesn't seem to be making a whole lot of difference. All right, and then here we have the reverse osmosis filtered water. We have about 31 parts per million. So that's actually a really good reduction from 344 all the way down to 30. And yeah, so we'll go ahead and take a look at what that filter actually looks like down there and how it works. And then we'll move on to the next one. This is my under sink here, and you can tell because that's my upper sink up there. And one thing I'm going to point out real quick is you'll see there's a faucet right there. That is my faucet for the reverse osmosis water, so when you get the water, it will actually come out of there. Now, this right here looks like a hot mess because it is. Essentially, the number of parts in the footprint for this type of RO system is quite large, and you'll see the difference when I show you the other one. But essentially, you've got a set of filters like this right here, and you actually will have 2 to 3 maybe of these bottom filters there. And what's going to happen is your cold water intake, or inlet, I guess, your cold water from your piping will come in through here, go through each one of these filters, and these can be sediment filters or carbon filters, it depends on what kind you're getting. But then it'll come through a reverse osmosis filter on the kind of, say, middle stage. And this does kind of the main lifting here, where this is just basically a filter that's got really tiny holes in it, and like the water is getting forced through those holes, and that'll keep the particles out, a lot of them, but it'll still leave behind a lot of bad stuff here in front of the filter, and you have to have more water to flush that away, which is why these are extremely inefficient, because you really can't force that much water through, and you end up having to, without a pump anyway, and you end up having to flush away a lot of, okay water in order to get rid of those bad particles, and you only get, for every 1 gallon of good, clean, pure water, you're getting about 3 gallons of wastewater, which is, not very efficient. But anyway, it'll go through the reverse osmosis filter, then it'll go through your final carbon filter here, and then go to the tank, and then on its way back out of the tank, which is this yellow line, it'll come back through this white line to your faucet. And of course your color lines are, different. You also get this black line, which is a wastewater, and again, these could all be different colors. Who knows? It depends on what you buy. But the theory is going to be the same. You're going to have an inlet water, a wastewater, a water to your tank, and then a water to your faucet. So you end up with 1, 2, 3, 4 hoses and tubes that got a snake all over the place. Plus you have this big unit that's got to sit in there, and you got the big old tank that's got to sit there. As far as installation, it's really not that complicated. For the most part, you're just plugging in lines to where it tells you to, and then hooking up a couple easy to make connections with your water supply. And probably the most complex part of this is really drilling a hole in the drain for your sink, because that is going to be where the wastewater is going to go to. But yeah, it's a very large system, so I'm not a big fan of it. So here's what I've gotten to replace it. This is actually the type of tankless reverse osmosis unit that you can find. These are about $250. Not much different than the other reverse osmosis, except obviously there's no tank. The other main difference with these is electrical. You will need electrical in order to make this work. So unlike the tank system, you don't have basically constant pressure when there's no power. This has to have a pump to make it work. So you need electricity to make this work. But on the other hand, this does have another benefit of when you need to change filters, you basically turn it and pull it out. This is so much easier than the other one, because taking those filters off, you will almost always get water all over the damn place, because it's just impossible not to. There's always going to be some residual pressure in there, and water's going to pop out, trust me. But this seems like it's going to be pretty nice, and we'll see for sure. But this one, only 3 hoses come out of it, and all 3 connections seem like they're pretty easy. They're right here in the back, so it should be pretty nice. I'm going to get this installed, and then we'll test it out and see how it works in comparison to the other one. I will say that the one thing that does kind of suck about not having a tank is if the system, if my water gets shut off, I do still have at least, a few gallons in that tank. So, worst case, water shuts off. I know I always have, about 3 to 4 gallons of clean drinking water from that tank, but that's going to be gone once I replace it. But I'm actually okay with that, because realistically, bottled water is not that hard to come by. And if I know something's coming, I can just store some water up in different containers anyway. So we'll be good. But anyway, I'm going to get that going, so I'll see you when it's all installed. I've gone ahead and I've finished installing everyththing I needed to get this tankless unit in, which was basically putting a new outlet back there that you can't really see, and just plugging up the tubing like it's supposed to be, pretty much. So all the plumbing's done, and that's it. It's one nice small little unit. And the only kind of weird thing that kind of sucked about installing this thing actually was the startup on it. So you actually have to let it run, and by run I mean you have to actually have water going through it for 30 minutes. Like, no joke, 30 minutes. That's a fair amount of water to go running down the drain, but I mean, all right, it is what it is. But I guess that's a thing you do with every new filter. So every time you get a new filter, expect to throw out a few gallons of water. But that's it. Now let's go ahead and test it and see if it's, worth it, or any better or any worse than the tank unit. So I've got my unit installed, my RO unit, that is, the new one. That's that unit, not any other unit that I possibly could be talking about. Anyway, that's installed. I've got my glass here, which I'm going to fill with some water. You'll notice that when I turn this on, it does make somewhat of a pump noise. You may or not notice, it's hard to tell. But there is a little bit of a noise there, and the flow isn't like incredible or anything, but then again, neither was the other one. But I'll put my tester in it, and we'll see what we get here. Alright, so we got about 15 parts per million. That's a pretty decent little improvement over the old one. The other one was a little bit higher. I think it was, 30, 40? I can't remember, it was a little while ago. But it's not bad. Turns out that's a pretty good reading. I mean, it's close to 0, and that's, anything below 350 is probably drinkable. I know that, because I've drank out of the tap before. Now, as far as how does it taste, It tastes like water. It tastes exactly like water. And if I compare that to the tap water, yeah, that tastes like water too. They both taste basically the same. So, you know, to quote the Goonies on as far as like, you know, can you drink it? It's wet in it, so drink it. That's it. So, yeah, I mean, it's water, man. I can't really say there's a lot to it. It's if you could drink out of the tap, drink out of the tap. If you want to get one of these because you want to make sure you have clean water in the event of some other weird stuff, by all means, get that. It's good. The only downside to this newer one that I got is the startup was, I think, I don't know if I said this before, but it was about 30, well, not about, it was literally 30 minutes of waiting for this thing to flush out before you can actually use it, which is kind of a pain. But, you know, other than that, I mean, that's a once a year type of thing. So having to do that once a year is really not that big of a deal. You might lose a couple gallons of water doing that, but otherwise I think you actually save a lot of water compared to the tank model because it only uses 1 gallon per 1 gallon of waste as opposed to 1 to 3 gallons of waste or 1 to 2 gallons of waste. But anyway, that all being said, I hope you guys enjoyed the video. I tried to inject some humor into it, but I mean, realistically, it's water. I don't know how to make water funny. It's the most basic building block of life, and I've never looked at a lake and laughed because it was funny. It's just, unless, I mean, maybe it was on fire. If it's Michigan, it's on fire. That's fine. Anyway, thanks for watching. I'll see you on the next one. Until then, try not to die.